Another interesting projectile motion question in SC Verma, question number 34. It's interesting because it's not just based upon simple formula. You need to apply some tricks to solve it, and it looks simple initially, and it could be made more interesting but because of the but we have used the yards and something like that. But let's solve it. In a soccer practice session, the football is kept at the center of the field 40 yards from the 10 feet high goal post. The goal is attempted by kicking the football at a speed 64 feet per second at an angle 45 degrees to the horizontal. Will the ball reach the post? And there may be quite a... So this is the center of the goal post, and they are trying to throw it at and making an angle 45 degree to the horizontal, and we have a goal post of height 10 feet. We need to know if this football will enter into this goal post. What are the things we are given? This distance is given as 40 yards. I think they did not give it in meter because these are the standard measurements of a football court. And this speed is 64 feet per second. So what are the reasons, what are the conditions in which this football will enter into it? Or what are the conditions in which it will not enter this goal post? The one thing is where it cannot reach it. If you, let's say, if this speed is so slow that its max, we already know that its angle is fixed. So if, let's say, if its range is less than 40 yards, then it will not reach the goal post at all, and we will solve this problem. So let us first see if this is the case, for which means we are trying to find its range. Let us say if this range is or this 40 yards is equal to 40, 1 yard is 3 feet, so this will be equal to 120 feet. If we calculate this range using this velocity, these angles, we will find this range R. So R is equal to u square sine 2 theta divided by g, and u square is 64 square into 64 square. Sine 2 theta is sine 90 degree or 1. He's already shooting at for the peak maximum range. Now g is in feet per second square, which will be 32.2. I will keep it 32 for the simplicity. And how does 32 come from? This is, we have 30. G is 10 meter per second square, and 1 meter roughly has 3.3 feet. So this is roughly equal to 33, or you can take it 33.2. Actually, exact value is 32.2 feet. So anyway, 332 into 2, this is 128 feet. So the range is not less than 120 feet. It's more than 128 feet. In fact, this range looks like, if there are no goalposts or anything, it's going to reach at 128, and this is the 128 feet distance. But is it necessarily going into the goal post? Maybe it's not. Think about it for a second. Under what condition it will enter into the goal post? Let us say its trajectory is like this. The goal goes over leg, and 124 feet, 28 feet lies such that it goes, I should draw it a little better, like this. It goes a little above the goal post, so it does not enter into the goal post. Or it can go like this, trying to reach here through that goal post. So the condition is whether at 120 feet at this particular point, the height of this trajectory is less than 10 feet or more than 10 feet. Understand it? If it is more, if the height at this particular point, if we can calculate, comes about to be more than 10 feet, the football is not going to enter into the football pit. If it is less than that, then it will enter the football pit. So how do we solve it? What is our approach? Think about it. How do we solve it? What we will do is, we will get rid of this 128 thing. Now, coming back to 128 feet, what I am trying to do is, I am trying to find out how much time it takes to reach this 128 feet distance right here. And at that particular time, we will try to find out this height. So how do we do that? This time t, to calculate this time during this, we will take this horizontal distance and we will make use of the horizontal component of this velocity. Again, the separation of the horizontal and the vertical. So t, this time, this will be equal to the horizontal distance divided by the horizontal velocity. Horizontal distance is 120 feet, and this is divided by the horizontal component of this velocity, which stays constant because there is no acceleration working in the horizontal direction. This is 64 cos 45 degree. This is our time. 120 feet divided by 64 cos 45 degree. Now we come back to our vertical displacement. During this period to this period, we have a vertical speed of 64 sine 45 degree. And we don't know the vertical speed. We will use the formula in vertical direction. Let us apply S is equal to ut minus half gt square. S is our vertical displacement here. U is the initial velocity, which is 64 sine 45 degree. T is the time which is taken from here to here, which we got it from here. 120 divided by 64 cos 45 degree minus half into g, again we will take 32 multiplied by t square is 120 into 120 divided by 64 into 64 into cosine 45 degree whole square. Let us say, what is this value of height? Is it here or is it here? Sine 45 degree and cos 45 degree, both are same. 64 cancels. This is 120. Very simple. 32 multiplied by 64 is 2 here. Cosine square 45 degree is 1 by 2. This cancels here. Things are getting simplified. So this will become 2 into this is 60. 4, 16. This is 30. So this is 60 into 30 divided by 16. I hope I am not making a calculation mistake. This is 15. This is 4. Dividing by 4 bosses. This is 120 minus 450 divided by 4. 120 minus 4, 1 times 4, 1, 5. 4, 3. This is coming negative, which means that there is some calculation mistake. U is T is equal to 120 divided by 64 cos theta. This is good. UT is 64 sine 45 multiplied by T, 120 divided by 64 cos 120. This is good. Half gt square, and time is 120 into 120 divided by 64 into 64 cosine 45 degree whole square. These things look good. So cos 45 degree, this cancel. 32 into 2 is 64. I'll write it this thing again. Half into 32 into 120 into 120 divided by 64 into 64 into cosine 45 degree whole square. This cancels. 32 into 2 is 64. This is 2 goes, this is 60. So we have, and then we have 16 here and 30 here. So 60 into 30 divided by 16. This will be 15. 450 divided by 4. Oh, I think I was doing right. 4 1 times 4, I thought there was one remainder. And then 4 1 times 4. Okay, there is no 1 here. That was the mistake. 4 1 times 4. 1 0. 4 2 times 8. And then 12.5. This will be equal to 7.5 meter. What does that mean? That this ball is coming here and it's going to hit somewhere at 7.5 feet above this ground, and that means that the ball is going to go into the goal post. If this result would have been something like 12 feet, the ball will not go into the goal post. Very good question. The only thing I would have liked to it is that they had not asked, given the yards, and you have to calculate G in terms of feet per second square, and we are not very good at these things because I also had to refer to the formula before coming to the solution. Doing the solution, I had to change the meter per second square to the yard. But still, with this kind of problem, you can do more problems like this where you are required to find the vertical height at any given range. So that is the key concept. The key concept is how to find the vertical, this not only the maximum height but also a given height which happens at two different points for a given range. That is the key thing in this problem.